Welcome to the deep dive. Today, we're looking at something pretty groundbreaking. 1 trillion parameters. That used to be the stuff of, well, sci-fi, right?
Absolutely. Confined to the biggest labs behind very closed doors.
But now, Ring 1T has sort of kicked that door open. It's made this massive scale, accessible, open source.
Yeah, it's a big deal. If you're working in areas like competitive programming, high-level math, or anywhere you really need fine-grained control over AI reasoning.
Then this deep dive is definitely for you. We need to understand what the shift means.
Right. So Ring 1T, it's more than just that headline number, the trillion parameters.
Okay.
It's an open source mixture of experts model, MOE, built with that 1 trillion total parameters. But the key is the focus. It's aimed squarely at deep reasoning.
You mean tasks that force the model to really think, not just pattern matching?
Exactly. Things like formal logic, complex problem solving, competition-grade math, stuff that needs extended internal computation.
So, our mission today is pretty clear. We're going to unpack the technical breakthroughs that actually made this possible as an open source project. How did they do it?
And we need to look at its performance. How does it stack up? We'll have to compare it, inevitably, to closed systems like, say, GPT-5.
And then bring it back to the practical side. What does this open weight model really mean for you, the listener, if your work depends on having control, on reproducibility?
Yeah, we've synthesized the technical analysis for this. We've looked at the architecture, the unique engineering solutions they came up with for training stability at scale, the benchmark results, which are pretty sharp, actually.
And deployment notes, too.
And deployment notes. The goal is to give you the synthesis you need to go from just knowing about Ring 1T to understanding how to potentially use it, and maybe more importantly, why it matters strategically.
Okay, let's dive into the architecture first, because honestly, 1 trillion parameters sounds terrifying from an operational standpoint. How did they manage that scale but keep inference speeds, usable?
Well, that's the elegance of the mixture of experts design, the MOE approach.
Right.
It has 1 trillion total parameters. That's its knowledge capacity, its potential depth. But the crucial part is only about 50 billion of those are actually active for any given token prediction.
Okay, so it's not like the whole trillion parameter brain is firing for every single step.
Exactly. That's what keeps the throughput reasonable while still giving you the benefit of that massive scale. It's optimized for depth, for reasoning power.
And it's those reasoning tasks that need that extra capacity. You mentioned it follows the Ling 2.0 architecture and has a long context window.
Yes, and that long context window is a really big practical advantage.
How so?
Well, think about feeding it code. You can potentially give it multi-file code bases, not just snippets. Or for math, you can provide these long, complex proofs or chains of thought without the model losing track halfway through.
That avoids the truncation problem or the context getting lost.
Precisely. And the strategic significance here, well, it's huge. For years, this kind of trillion parameter capability was locked away, proprietary. Now, with open weights, you can actually audit the training decisions. You can build directly on top of this powerful base model. And maybe most critically, you can deploy a frontier-level system without being tied to a specific vendor or a third-party API that might change on you.
That freedom from vendor lock-in. That sounds like a massive strategic advantage, especially for research labs or startups trying to carve out a niche.
It really is.
But let's push back a bit. Does the initial cost of running this beast needing serious hardware actually create a bigger gap? Smaller teams can afford an API call, but maybe not a dedicated cluster.
That's a fair question, and it's definitely a consideration. But the source material argues that for serious research, the strategic win of control and transparency outweighs that initial infrastructure hurdle.
So what are the concrete wins for the community then?
You get 3 key things, really. First, a real working trillion parameter model as a reference point. Second, you get the training recipe, basically a blueprint for how they achieve stability at this scale. You can study it.
Okay.
And third, it just resets the baseline. It proves that open can genuinely compete at the very top tier. You gain the right to own your inference pipeline, something closed APIs simply can't offer.
Okay, so we get why open weights at this scale are a big deal strategically, but open doesn't mean much if the system is constantly falling over, right?
Right.
Scaling a MOE to 1 trillion parameters, especially trying to train it with reinforcement learning for better reasoning, that sounds like hitting stability cliffs left and right.
Oh, absolutely. It's a major challenge.
Yeah.
The Ring 1T team seems to have tackled this with 3 really interesting innovations.
Okay, what are they?
The first one they highlight is called Ice Pop.
Ice Pop. Intriguing name. What problem is it solving?
It's tackling noise during training. When you're training these massive MoE models, particularly for tasks needing long chains of thought, the way the model behaves during training can diverge quite a bit from how it behaves during inference.
Okay.
And reinforcement learning is sensitive to this. IcePop essentially acts like a filter. It identifies tokens where the training probabilities are getting weird or where the gradients are becoming unstable.
And it just drops those updates?
Basically, yeah, it masks those tokens or clips the unstable gradients. The goal is to get cleaner, more stable reinforcement learning signals without slowing down the actual sampling process too much. It's crucial for teaching complex reasoning effectively.
Right, filtering out the garbage signals. Makes sense. But what about just the raw efficiency? Training something this big, the throughput must be a nightmare. You need thousands of GPUs working together.
That leads right into the second innovation, C3PO++E.
C3PO++C. Okay, points for the name again. What's the bottleneck it addresses?
Idle hardware. Traditional reinforcement learning involves these long rollouts, simulating long sequences of actions. During that time, a lot of expensive GPU hardware can end up just sitting there, waiting for the whole sequence to finish.
Right, inefficient.
Very. C3PO++ changes that. Think of it like breaking a huge task into smaller chunks. It chops these long rollouts into budgeted slices. If a slice isn't finished within its budget, it gets paused and put into a buffer.
Okay.
Then, under the next updated policy, the system picks up those unfinished trajectories and continues them. So instead of one long blocking process.
You get a continuous pipeline of shorter, resumable tasks. Keeps the GPUs constantly busy.
Exactly. It significantly improves throughput and cuts down the wall clock time needed for training.
Clever. So IcePop for stability, C3PO++ for efficiency. What's the third piece?
That's a system. This is described as the core RL backbone, the infrastructure that ties everything together.
Okay, what does it manage?
It unifies the training and inference loops, handles the rapid peer-to-peer exchange of model weights between GPUs, which is vital in MoE, and manages GPU memory very efficiently to minimize fragmentation. Fragmentation can kill performance at this scale.
And how does it coordinate all this?
It uses asynchronous orchestration. They mention a single controller, SPMD flavor, single program, multiple data. Essentially, it's a sophisticated system designed to keep thousands of GPUs coordinated and working productively. This kind of underlying infrastructure isn't flashy, but it's absolutely necessary to make trillion-parameter open research feasible. It's the stability recipe.
All right, let's talk results. Engineering marvels are great, but does Ring-1T actually perform? Where does this focus on reasoning really show up in the benchmarks compared to other open models?
Yeah, the proof is definitely in the performance on hard reasoning tasks. It's putting up state-of-the-art numbers among open-weight models, and honestly getting pretty close to the big proprietary systems in specific areas.
Like what? Give us some numbers.
Okay, look at competitive math. On AIME 2025, it scored 93.4%. On HMMT 2025, 86.72%. These are tough Olympiad-style problems.
And that consistency across different types of math problems is key.
It is. And it's not just math. In competitive programming, it achieved a 2088 rating on CodeForces. That shows real coding and algorithmic capability.
Wow.
But maybe the most striking result mentioned in the source material. It reached a silver medal level on the International Mathematical Olympiad, the IMO.
The IMO? Seriously?
Yeah. By solving 4 problems in a single attempt. That's not just pattern matching. That requires genuine multi-step logical deduction. It's impressive.
Okay, but hang on. Let's play devil's advocate. We know models like GPT-5 excel at broad general knowledge, maybe tool use, have slick interfaces. Isn't Ring-1T just a super specialized, incredibly expensive niche tool, mainly for high-end researchers? Is there a broader appeal?
That's the core debate, isn't it?
Yeah.
And the appeal isn't necessarily about having the smoothest chat interface. It's about control.
Explain that.
While a model like GPT-5 might win on breadth, maybe polish for a non-technical user, it's fundamentally a black box. You use the API, you get results, but you don't own the model. You can't inspect it deeply. You can't modify its core.
Whereas Ring-1T...
Ring-1T gives you the weights. It's for the developer, the research lab, the startup that needs to build on the model, maybe fine-tune it heavily for a specific internal task, or build agents where they need absolute certainty about the model's behavior.
So it's the classic trade-off. Maybe less polish, but you get openness, reproducibility, and total control.
Exactly. And the performance gap on its core strengths, math, logic, code, is surprisingly narrow based on public benchmarks.
So how do you see teams actually using these in the real world? Pick one or the other.
The analysis suggests many smart teams will likely use both. They might use a polished, closed system like GPT-5 for broad customer-facing interactions where safety guardrails and general knowledge are paramount. But they'll deploy Ring 1T for internal tools, specialized research projects, or tasks requiring complex, verifiable reasoning chains, or where they need to inspect every step.
Okay, let's get practical. For someone listening who wants to try out this reasoning power today, what's the easiest way to get started with Ring 1T?
The quickest entry point is usually a hosted web playground. Several cloud platforms and partners are starting to offer access.
Any tips for using those playgrounds effectively?
Yes, crucial tip. Don't just give it toy prompts. Write a poem about my cat isn't going to show you what's special here.
Right, it's a reasoning engine.
Exactly. Feed it a real challenge. A difficult math problem from a competition, a tricky debugging scenario with some code. Maybe ask it to outline a formal proof. That's how you'll actually see its capabilities.
Okay, and what about developers who want to integrate it into their applications via API?
Good news there. It typically uses an OpenAI-compatible SDK. So if you're already set up for that.
Switching is relatively minor.
Often, yes. It usually just involves changing the base URL endpoint, specifying the Ring 1T model name, and using the appropriate API key.
Any parameters to keep in mind when making those calls?
Remember, reasoning takes compute. So, be generous with max token setting, especially for complex tasks. Use a moderate temperature.
Yeah.
And look for specific flags if the API provides them.
Mm-hmm.
Sometimes there's a thought mode or similar flag to explicitly trigger the deeper reasoning paths.
Got it. Now the elephant in the room, can I download this and run this trillion parameter beast on my high-end gaming PC?
A dream.
Mm.
The short answer, unfortunately, is no. Definitely not.
Not even close.
Not even close. We're talking a multi-node cluster setup. You need multiple machines packed with data center-grade GPUs. Think A100s or H100s. You need high bandwidth interconnects between them, like NVLink or InfiniBand. And you need an inference engine software stack that's specifically built to handle mixture of experts models efficiently.
So it's serious iron, data center territory.
Absolutely. Think something like 8-way tensor parallelism combined with 4-way pipeline parallelism spread across maybe 4 or more powerful nodes. It's not a desktop workload.
So if I want to experiment with the model itself, I need access to a cluster or I need to use a cloud provider's service.
That's right. Now, you can do useful things on a powerful workstation. You could potentially run smaller distilled versions of the model, or you could fine-tune lightweight adapters like LoRa's or certainly prototype and refine your prompts. But for full-scale inference, with the trillion parameters active,
You need the big guns.
you need the big guns.
And finally, let's talk cost. Open source means the model weights are free to download, but running it, that sounds expensive.
It is.
Right.
Free as in puppies, not free as in beer, right?
Okay.
You don't pay for the model code, but you absolutely pay for the compute time.
How do providers typically charge for this?
Usually metered by tokens processed, similar to closed models. Often, they'll have different rates for input tokens versus the generated output tokens.
What's the main driver of cost when using Ring 1T?
The complexity and length of the reasoning. A simple rule of thumb. The longer the model has to think, generating intermediate steps, exploring possibilities, the higher the cost.
So if I ask for that detailed mathematical proof,
Expect a bigger bill. The model needs to activate those 50 billion active parameters token after token, step after step. You're paying for that powerful reasoning capability. So your pricing is directly tied to how demanding your prompts are and your tolerance for latency, because deep thought takes time too.
given that this model is so tuned for structured thinking, just throwing casual, vague requests at it seems like a waste of expensive tokens. What are the best practices emerging for prompting Ring 1T effectively?
Quality over quantity. Give it fewer prompts, but make them much better, much more structured.
How so?
It loves clear definitions. For almost any task, math, logic, code, explicitly state the given information, define the goal precisely, and list any important constraints. You're essentially setting up the problem formally for the model.
Feeding it the structure it expects.
Exactly. And there's that interesting trick mentioned for balancing speed versus reliability.
Right. Tell us about that.
It comes down to how you structure the request. If you need an answer quickly, first ask Ring 1T for just a high-level plan or outline. Then, in a separate step, ask it to execute that plan concisely.
Okay. Plan first, then execute.
But if reliability is paramount, if you need the most accurate, well-reasoned answer, you flip it. Ask for the full, detailed, step-by-step chain of thought first. Let it really work through the problem. Then ask it to summarize or extract the final answer from that detailed reasoning.
So you force it to do the deep thinking explicitly before giving the final output.
Precisely. It ensures the MOE's reasoning pathways are fully engaged.
What are some of the early field notes saying? Specific behaviors people are noticing.
Some interesting patterns. In coding, users report it's quite patient with refactoring tasks. If you give it a failing unit test, for example, it often doesn't just patch the bug. It might also explain the logical invariant it was trying to preserve or fix.
That's useful. What about math?
It seems to have a bias towards constructive proofs or solutions, actually building the answer rather than proving its existence indirectly. And if it starts to go off track on a long problem,
How do you correct it?
the fix seems to be re-anchoring it. Give it a clear, formal goal statement again to get it back on the right path. The consistent theme is clear. Structure in your prompt gets you signal, gets you good results. Vague prompts just burn tokens.
So, looking beyond the benchmarks and the tech, what's the real legacy here? What's the lasting impact of Ring 1T?
I think it fundamentally resets the baseline for what's possible with open source AI. It provides a concrete working example of transparent reference implementation of achieving stable, long-horizon reinforcement learning at the trillion parameter scale.
And having that reference is key.
It is, because now researchers, students, startups, they have the open code, the open weights, and details about the training process. They can conduct experiments, they can debug complex AI systems, they can prototype new kinds of agents, all built on a frontier-level foundation without needing the resources of a giant corporation.
Okay, let's try to summarize this for decision makers. The core identity. Yes, the weights are open. Its standout strength is in math, logic, and competitive programming.
Right. But it's not necessarily the best choice for, say, broad general knowledge or polished multimodal applications where closed systems might still have an edge.
And the key trade-off to acknowledge is the cost and latency associated with asking it to perform long, complex reasoning tasks. That's the price for that capability.
Exactly. Ring 1T's real achievement is proving that open models can compete right at the cutting edge of complex thought. It points towards a future where more of the fundamental AI research is driven by these accessible, transparent systems, not just happening behind closed doors.
So the source material seems to suggest two clear next steps for you, our listener, now that this kind of power is becoming available.
First, take a real problem you're facing, something genuinely challenging, not just a toy demo, and actually try Ring 1T on it. See what it can do.
And second,
Share what you find. Create a minimal, reproducible example, not just of what worked, but maybe even more importantly, what broke. Share that back with the open source community. That's how the ecosystem improves.
we'll leave you with this question then. With this new level of open access to trillion parameter reasoning power finally here, stable and transparent, what demanding logic, coding, or mathematical task will you tackle first?